So let's consider vector u and vector v. I'm going to tell you that these two vectors are parallel. I'm also going to tell you that vector v is twice as long as vector u. Now that we know this, I'm able to say that vector v is twice as long as vector u. Now again, because these vectors are parallel, I am also able to express vector u as vector v. So vector u is equal to, and because it's smaller than vector v, I know I need to multiply by something less than 1. And in this case, since vector v is twice as long as vector u, I can say that vector u is 1/2 of vector v. Now that I have these two scalar equations here, I can easily compare them. They are the exact same equation, so if I take, it doesn't matter which one, but if I take this vector v equation and I divide both sides by 2, you can see that I have the exact same equation as above here. So basically, now that I have these parallel vectors, they go in the exact same direction, they're just not the same length, I am able to write some equations to relate them. I know you're probably thinking, what happens if you have two vectors that are parallel but go in opposite directions? So I can tell that these go in opposite directions because of where their tips and tails are. What I haven't told you yet, but I am right now, is that these vectors are very similar to the last vectors we looked at. Vector b is twice as long as vector a. So because they're opposite directions, I can't write the equation the exact same way, but what I can say is that the magnitude of vector b, or the length of vector b, not including direction, is equal to 2 times the magnitude of vector a. So because these vectors are opposite directions, I can write a similar statement. I can say that vector a, one minute here. I can say that vector a is equal to 1/2 the length of vector b, but because it is in the opposite direction, I need to include this negative. And similarly, I could say that vector b is equal to 2 times the length of vector a, but again, because it's in an opposite direction, I must make this negative. So I hope this helps give you a visual and helps clear up some of these ideas about scalars. But like always, if you have any questions, please don't hesitate and reach out to me.